Hi, good evening guys. Today we're going to look at isoflurane. Isoflurane is one of the volatile anaesthetic gases. We're going to have a look at the presentation, mechanism of action, the usage, some of the effects and side effects, some of the pharmacokinetics, and then we'll have a look at some of the specific values associated with the volatile gases. Isoflurane itself is a halogenated ethyl methyl ester. It's a structural isomer of N-fluorane, and as we said, it's a volatile anaesthetic gas. It's a liquid at room temperature, and it is inert when it's in contact with metal, but it is soluble in rubber. It's non-flammable and has a pungent smell, which means it's not ideal for gas-based inductions. When we think about the mechanism of action, as with all the volatile anaesthetics, it's not completely understood. There is a hypothesis that it likely binds GABA, glutamate and glycine receptors within the central nervous system, and also some interactions with potassium channels, but like I said, we don't completely understand. When we think about the usages of isoflurane, predominantly it's used to maintain anaesthesia. When we look at the effects and the side effects, if we look at the respiratory effects, it's a respiratory depressant. It reduces minute volume, it causes upper airway irritability and cough and breath holding, but it does also produce a marginal amount of bronchodilation. When we think about blood pressure and cardiovascular things, it essentially leads to a drop in systemic vascular resistance with a marginal reflex tachycardia. When we think of the central nervous system, it produces a balance between reduced cerebral oxygenation demand and minimal increased cerebral blood flow, and at a concentration of a MAC of 1, autoregulation is maintained. When we think of the pharmacokinetics, only 0.2% of it is metabolized and the rest of it is just left as it is, and there is no toxicity associated with metabolites of isoflurane. Due to its CHF2 group though, and this is structurally similar to N-fluorane and desflurane, it may react with dry soda lime, and that produces carbon monoxide. This relates to circle systems and the leaving of dry gas circulating in the system over a period of time. If we think about some of the specific volatile gas values, the blood gas coefficient is 1.4, the oil gas coefficient is 98, and the MAC value is 1.17.